Hello guys, welcome to my YouTube channel. So today we are going to see SMOTE technique. So let me put the name here for the better understanding of yourself. So if I use the row here, so we can see that we are going to see SMOTE. So what is the full form of SMOTE? So it's a synthetic minority oversampling technique. So in SMOTE, what we are doing, we are just generating the new data to match our categories. So let me explain you what is the categories and why SMOTE is required for us. So now you can see that. So here I have some data points. So you can see that I have some columns. It's a column of the cuisine data. So in the cuisine, I have many cuisines like Indian, Chinese, and Thai, and all other there. And here are some parameters. So based on this parameter, I just want to predict the cuisines, what the cuisines is. So here is the almond and all the parameter. There are lots of parameter present, and this is the numbered column. So let me explain you how much cuisines are present in my data. So if I use cuisines with the unique method, so you can see that I have different number of cuisines. Let me use the shape here as well. So you can see that I have cuisines of Indian, Thai, Chinese, Japanese, Korean, and all of this. Now the shape of this database, which contained 200 2448 rows and 385 columns. So these are the shapes, but you can observe that this unnamed column is not required for us because it's just increasing the number of the things, right? It's a just numerical serial number column. So what I will do, let me drop this column. So we use the drop method here with the labels equal to, and use this column. I'm just copy pasting the name, and x is equal to 1. So if I do that, you can see that my column is dropped, but it's not actually dropped. So I use the in place equal to true attribute to drop the actual column in my data set. Now I can see that if I use the head function, there is only that column is already dropped. So now I have all other columns, right? And I have cuisines of all the different categories. Now let me check that how much Indian cuisines record present in my data, how much Thai cuisines record present in my data, and things like that. So for doing that, we use the cuisines column again. So here I am using the count value functions. Okay, I think it's not a value, it's a value count. So this function will count how much values present in my dataset. Now let me see where actually sometimes there is kernel issue because its database is little bit of long, so that's why it's taking little bit of time because of the CPU utilization and all. So you can see that I have the 4 cuisines which have Korean has the lots of data points, Indian have few like 590, Chinese have few data points, Japanese have few data points, and Thai has the another number of data points. So you can see that if I train my model with these data points, so my model will be biased to the Korean cuisines because it contains lots of numbers, means lots of data points present for only the Korean cuisines. Indian cuisines have the different number of parameters. So my model will be biased to the Korean cuisines. So how we can solve this problem? Because we need to make sure that our model is not biased to any other cuisines. It's just taking the numbers and generating the cuisines without any biasness. So for solving this problem, what we need to do, we need to match all the columns with these Korean cuisines, which means that we need to increase our data point to make sure that my Indian cuisines have also the 799 records, my Chinese cuisines also have 799 records, and my Japanese cuisines also have, and Thai cuisines also have 799 records. So how we can do that? One method for doing that is we just go to our manager and say that okay, I don't have the I don't have the exact number of data points, so please give me the more data. That is the one way. Other way is that sometimes there is the condition that we can't get the new data for the different cuisines. So in machine learning there is one method which is called SMOTE technique to help us to generate or match those all the data points. So how SMOTE works, let me explain you in the graph. So you can see that I have the black and red. These are the two we can say data sets in my machine learning model. So now in my this is my x-axis and this is my y-axis. In my y, you can see observe that my black data points have the lots of number of data points, but my red have only few number of data points. So I want to match my black number with my red number. So in that way I can make sure my model is not biased. So for doing that, what we need to do is, right, so how SMOTE technique works. So now you can observe that I have two data points right here. Two are the red data points. So what SMOTE will do, SMOTE will draw the line between these two data points and generate one new data point. Oh, let me use the red here in the middle of this line. So here is the new data point for red. So in this way I am generating the new data point for my underutilized oversampled class. So this is the way we generate the one data point, right? So now again for the other points as well, it will do the same things. It will draw the line between these and these and generate a new data point between this here is. So maybe you observe that there are some there is the possibility that if I generate the line and my new line which is generated, the new point which is generated which exactly the point which belong to the another class, there is the possibility for this. But this condition will came very less. There the probability of getting this condition is very less. So in that way we are not taking care of that things. So and in machine learning model as well, these are the very less condition that we are taking this. So sorry for that, actually I just need to draw the one single line, and here if I use the another method, you can see that my new point is generated here. If now you can observe that it right now it generated 3 new points, right? Then again it will use the SMOTE for the all other red points like this one and generated new one as well, all the data points, and match my and increase my number of red data points in a way that it matches to the black thing. So this is the actual logic behind this SMOTE technique, how SMOTE techniques work in the background. But you don't need to do anything, everything is handled by the libraries. So now let me go here and use those. Like you can see that I have the different data points. Now let implement the SMOTE in our model. So for implementing the SMOTE, you need to install SMOTE first, because SMOTE is not present in your sklearn library. So you need to use the imbalance library. Let me use here something like this one. You can see that this library is already installed in my system, so that's why it's not taking lots of time, but in your system it takes some time. So I just import the from import imbalance, then oversampling, import SMOTE. So you can see that my SMOTE is initialized successfully. This library is not present in sklearn, so that's why we use the imbalance library for that. So let me initialize the SMOTE. Here is the SMOTE things. I just initialization, then I just need to pass something for it. So for passing it, let me use .fit resample method. That's the method which is very required for it. So I am using here the little bit of SMOTE in lowercase to just initialization, make sure. Okay, it will require some argument which is like the x and y. So for passing the x, what is the x here? So you can observe that this my almond, allergic and all other things which is responsible for my increasing or predicting my cuisines which is required. These are all the input parameters. What is my output parameter? Cuisines are my output parameter. So now what we'll do, we just extract those input parameters from the df to our feature variable. So here I am defining two variable, feature and target. Now in the feature, I am just using the df dot drop. I'm not dropping the actually column. I'm just copying the all the methods inside that. I will explain you in the meanwhile in a second, right? How we can do that. So we can use the label equal to. I'm just using the cousins here. Now x is equal to. So this is the actually one method for doing that. So here you can, if I use the feature, so you can see that it actually dropped the column for my current database and copy and paste all this or assign those all the remaining columns to my feature data set. So it's not actually dropping the column from my df, it's because we didn't use the in place equal to true attribute. So this is one of the technique people use for the assigning the input feature and output feature. For the output feature, what we'll do, for output feature we use the directly like this one and cousins, only this one, this column. So in that way our output is also ready and our input is also ready. Now let me use the feature dot shape comma target dot shape. So in that way we can observe that you can see that I have 448 data points and these are the columns, 383 columns. So now I just need to pass this input feature and target to my resampling method. So for passing that we use the features here and comma we use the targets here. Let me see like what we did use. Okay, this is now something which we need to use. Okay, what is saying? It's saying that we don't have this. I just used the parenthesis by mistakenly, so that's why it's giving me the error. So now triple as. So I'm just copy pasting those things because they have maybe have some. So I'm just passing the input here and the target here. Okay, it means showing me, actually it's why it's giving me the error because I didn't rerun, because I run it's the first time, so the resample is done, so that's why it's giving me the error. Let me rerun everything again. Now it may giving me the different array which is like expect to the array, but we got the, okay, we need to use the reshape attribute. So for doing that, sorry, I just mentioned a feature here. Okay, now you can see that my resampling everything is done and my new data is like produced, but this data is produced, but here I just used to transform underscore feature comma transform target. Means what this will do, this will actually copy my all the things to my transform feature and transform feature. Means new data points will be we can use for this is the transform feature and transform targets. So now once that resampling is done, we can use let me see transform feature dot shape. So if I use the shape here, you can see that it's now before that means before the resampling, it giving me the row number of rows which is like 2448, but right now it is giving me the row which is like the 3995. And for the target as well, transform target dot I will use shape here. Now you can see that my all rows is matching to my all target rows count. So now it's actually we are done here because we just generate the data, but we need to observe that okay, is my data generated corrected or not. So how we can do that? We use the feature transform feature dot value counts Okay, so it will give me the something. Oh, use the unique. Okay, it's not a part of the data frame, so that's why giving me this error. So let me use the transform feature equal to pd dot data frame, and we use the transform feature again here. So now we use the transform feature dot value counts. Again it will give me the error. Let me check my before. Okay, here I just need to use target. So now you can see that in my target database, I have now Indian cuisines which have 799 records, Thai cuisine which have 799 records, Chinese cuisine which have 799 records, Japanese cuisine which have 799 records, and Korean cuisines which have the same 799 of records. So now you can observe that my data is now not a sample or not a bias to anything. It is like equal number of data points for present is present in my output or predicted class. So in that way I increase my data point, I increase my rows without going to my manager and saying that please give me the another data. I just synthetically generate the points, synthetically generate the uh, points for my other data sets. So this is the synthetic minority oversampling technique we use for the generating the synthetic data points. So these are data points actually we use for the making the machine learning model. So we can perform this, we can get those inputs and uh, produce the targeted output. So this is the my input and this is the my output for the new data points or machine learning model. So in this way I'm just explaining you this what is the SMOTE and how we can utilize it. So that's pretty much from my side. Thank you so much.